Hi everyone. Today we're going to look at this question under rotational kinetic energy stroke moment of inertia. The question says a cylinder of mass 50 kg has a radius of gyration of 0.2 meter. The cylinder is rotated by a belt at 4 revolutions per second. Calculate the rotational kinetic energy of the cylinder. Assume the cylinder rotates through its axis of symmetry. So if we try to say interpret this question for pidgin, e say cylinder dey wey be say the weight of that cylinder na 50 kg and that cylinder radius of gyration na 0.8 kg. Now e get belt wey dey connected to the cylinder wey dey rotate am and e dey rotate at 4 revolutions per second. The question na say calculate the rotational kinetic energy of the cylinder if that cylinder dey rotate through the center. Na wetin dem mean by axis of symmetry, if dey rotate through the center. Now the first thing we need to put here na to write out wetin physics dey call the parameter. In other words, write out those things wey dem give us. Now if you look through at the question, you go know say dem give us, the first thing dem give us na mass. So dem give us mass as equals to 50 kg. Now after the mass, they also give us the radius of gyration. So they give us the radius of gyration as 0.8 meter. After that, they give us, they say e dey rotate by a belt, which means e dey move, e dey go in a circular motion. So that is angular velocity. Now they say the angular velocity na 4 revolutions per second. 4 revolutions per second. Now before we go on quickly, remember say angular velocity we no dey measure am in revolution. So the first thing to do na to convert this to the normal unit, which is to rads per second. Now if you remember or you recall properly, we talk say 1 revolution na 2 pi rads. 1 revolution na wetin? 2 pi rads. Now if 1 revolution na 2 pi rad, which means say 4 revolution go give us wetin? Make we denote am by omega. So we fit quickly cross multiply. Multiply this cancel this. This times this go give us omega. Then you get 4 times 2 pi rads. 4 times 2 pi rads. And so the omega go give us 4 times 2 na 8. Then you know say pi na 3.142. Then retain the rads. If you multiply this for our calculator, we go dey get 25. So omega equals 25.132 rads per second. So this become our new value for omega. So now this value for omega now we go use when we continue our solving. Now that's all wey dem give us. Now they say make we calculate the rotational kinetic energy. Rotational kinetic energy. Now wetin dem no give us be that. Now remember say the formula for rotational kinetic energy na half omega square mr square. Now this formula, if you remember, we fit still write am as half I omega square. In case you no understand how we take get this I omega square, abeg look at our other videos. E dey really and explicitly explained for that video. Now, having known say rotational kinetic energy na the same thing as half moment of inertia and angular velocity square, no, na this formula we go use to get our answer. There are no two ways about it. Na this formula we go use. But now if you look clearly at this formula, you go see say moment of inertia no dey among the things wey dem give us, which means say the first thing we need to do na to find the moment of inertia. Now the particle wey dem give us or the object wey dem give us na solid cylinder, and the moment of inertia of a solid cylinder na half mr square. So na this formula we go use. So when we don find our I, then we come back, connect our I to this place and use am find rotational kinetic energy. If you also look well, we need mass and radius, but they no give us radius. Wetin dem give us na radius of gyration, but no be natural radius. So we also need to find radius. Now wetin we go do to find radius? Now there's a formula wey connect radius, normal radius and radius of gyration. So the first thing is we need to go look for the general radius of gyration of particles, and that one we get am as say I equals mk square. So this na the general formula wey connect moment of inertia and radius of gyration. Now if this one na the normal formula for moment of inertia of this particular object, while this one na the radius of gyration, and the two of them carry I, e mean say you fit also equate these two, which means this na mathematical rule. If A dey equal to B, A also dey equal to C, then you fit talk say B dey equal to C, because the two of them, this equal this, so this should also be equal to this. So the same thing here, this equal this, which means this should also be equal to this. So we go equate these two. So we go dey get mk square equals to half r square. So na radius of gyration na dey here. So let's try making k the set of formula. So we divide both sides by m, divide both sides by m. So this cancel this cancel this. It remain k square equals to half r square. We fit rewrite this as k square equals to r square over 2. Just in case you no understand wetin I write, wetin I do na just to multiply half multiply by r raised to power 2. 1 times r go give you r square, 2 times invisible one wey dey here go give you 2. Na how we get this one. So we still remember say k no dey alone, k still carry square, so we fit square root both sides. So you have k square square root am equals to r square over 2. You also square root am. Now this go kill this one, so k go dey equals to if you remember our law of surd, we fit separate these two from this umbrella, give each person im own square root. So you go get this over this. So each of them na don collect their own square root. Now this one go fit kill this one, square root go cancel square, so k dey equal to r over root 2. So this formula wey we just get now, this na the formula wey connect radius of gyration and normal radius, and na wetin go fit help us to get our r. Remember say before we go fit use this formula wey dey for here, we need to find our r. When we find our r, we connect the r to this place. When you connect the arrow to this place, then you go fit easily find your moment of inertia. After you find your moment of inertia, you connect am to this place to find the rotational kinetic energy. So back to this place. Now we don get this, let's go to the up. Radius of gyration, we get am as, they give am as 0.8 meter equals radius over square root of 2. When you cross multiply, you get r as equals to 0.8 meter multiplied by root 2. When you check this for your calculator, 0.8 meter multiplied by root 2, you go dey get your radius as 1.13 meter. So now we just successfully get our radius. So we need to come back to this place here, come back here to put our radius in here, so that we go fit get our moment of inertia. So make we come back to I equals half mr square. So I go dey equals to half, the mass na 50 kg multiplied by the radius wey we just calculate now na 1.13. So that's 1.13. E dey squared, so we also square am. So when you calculate this with your calculator, when you multiply all this, square this one first, multiply all this and divide it by 2, the answer wey you go dey get na I go dey equals to 31.92 kilogram meter square. Kilogram na for this, from this mass, then meter square, this one na meter. When you square this one, you also square this one to get meter square. So now we don get our moment of inertia as 31.92 kilogram meter square, but we never get to the end of the question. Remember, we define rotational kinetic energy. So all these ones na just the bypass, the side road wey go lead us to our answer. So we know say from here we find arrow, then we come here, come find moment of inertia. Now from here now we wan go back to looking for the rotational kinetic energy. So rotational kinetic energy, remember, na half I omega square, which is the angular velocity. So the rotational kinetic energy go dey equals to 1/2 times moment of inertia. We don get am for here as 31.92 kilogram meter square, then times angular velocity, we get am for here as 25.132, so 25.132 rad per second. Then we square everything. Let me rewrite it, make I write am for here. So this equals to 1/2 multiplied by 31.92 kilogram meter square multiplied by 25.132 rads per second, then all squared, because the omega dey squared. So when you multiply everything for here, you go dey get your rotational kinetic energy as equal to, you go dey get 10,083.82. Now the unit, just go carefully and bring out all the units wey dey for here. You get kilogram for here, you get meter square, then when rad raise to power 2, you go get rad square. When rad raise to power 2, you go get rad square. Second square raise to power 2, you also get per second square. But instead of writing all this, since na energy, remember rotational kinetic energy, and you measure energy in volts, so if you simply write the rotational kinetic energy as 10,083.82 joules. So this now na the answer of the rotational kinetic energy. Remember, say for physics, when you dey solve, no leave your units behind so that you no go make any mistake. Thank you very much for watching, and we hope to see you in our next video. No forget to subscribe so that you no go miss any of our videos.